we did more, because we gave weights. So it's not just a ranking that we obtained, it's a numerical value for weights. But now we have to put them together. So criteria compared each other. So this is my proposed matrix. And basically, of course, depending on the stakeholder, you get different evaluation. And basically, what I did here is to consider that the cost is more important, moderately more important than the reservoir storage and the environmental impact. And the cost is much more important, strongly more important than the landscape impact. Then, of course, keep in mind that this is a 4x4 matrix, so the evaluation becomes more challenging. So basically, now it's antisymmetric, so I can put 1/3 for the reservoir storage with respect to the cost. It's diagonal, so I put a 1 second term, and then my estimate is that the reservoir storage has the same importance that the environmental impact. This comes from the previous evaluation, where I gave the same ranking to the estimated cost with respect to storage and impact, environmental impact. And therefore, I put in the first row here, I put storage and environmental impact at the same level, and therefore the consequence is that when I compute the importance of storage with respect to environmental impact, I have to put 1. And then there is the evaluation of the importance of storage with respect to landscape impact. Let's put 3 there. And it's more important. I can see that storage is more important than environmental impact from the first decision, because you see that the cost is moderately more important than environmental impact, but strongly more important than landscape impact. It means that landscape impact is less important than the environmental impact. So basically, storage. So landscape impact is less important than storage. So when I compare storage with landscape impact, I have to put a value that is higher than 1. Okay, now environmental impact with respect to cost is 1/3, and then we have a 1, which is environmental impact with respect to reservoir storage, is given by the symmetry and the symmetry of the matrix. In the diagonal we have a 1, and then the environmental impact with respect to landscape impact, this is 3. It's the same value that I can find here, because reservoir storage and environmental impact have the same importance. And now I am done. It's 1/5, which is the inverse of 5 here, 1/3, which is the inverse of 3 here, 1/3 again, which is the inverse of this 3 here, and then 1 in the diagonal. So if I compute the weights, I come up with this result. The cost is assigned a weight of 0.52, and then I have a weight of 0.2 and 0.2 again for storage and environmental impact. Landscape impact has a weight of 0.08, and the consistency is fine. CR is 0.01. So basically what we concluded here is that a lot of priority is given to the cost as a result of the matrix that you can see on the top. Okay, now there is the computation of the ranking of each solution. So basically, let's refer to cross-section 10. For cross-section 10, we got a score of 0.19 for the environmental impact. And this must be multiplied times the weight of the environmental impact, which is 0.2. And then we got a score of 0.18 for the coast, which must be multiplied by the weight of the coast. And then we got a score of 0.79 for the storage. And the weight of the storage was 0.2. And then a score of 0.71 for the landscape impact. Should be multiplied by the weight of the landscape impact, which is 0.08. And then we come up with the result of 0.35. If you make some trivial consideration, you realize that the sum of the score for each of the solution must sum to 1. If they don't sum to 1, there is a mistake in the computation. Because the score of each solution with respect to each criteria, they sum to 1. And the weight given to the criteria, they sum to 1. So when you make this multiplication, you end up with a ranking through weights that sums to 1. So let's move forward then. For the other two computations, and you see that for 25 you get a score of 0.42, and for section 30 you get 0.23. And so basically you end up with your conclusion, the best alternative is cross-section 25. Okay, that's it. And there is one thing that I need to add now at the conclusion. And the one thing is that in my explanation there was a step where I was not rigorous, and I need to correct a little bit what I said. Because you may have noticed that I said that the eigenvector gives to you the weights, but then I said that the maximum value of the eigenvector should be equal to the dimension of the matrix. So there is an inconsistency here, because weights by definition should be lower than 1, and therefore the maximum value of a vector that contains elements that are lower than 1 cannot be equal to the dimension of the matrix. So there is an inconsistency. The inconsistency is that this is correct, and it's the weights that are given by the eigenvector, eigenvalues divided by the dimension of the matrix. This is the inconsistency that I made. I just said in the eigenvector you have the eigenvalues, and the eigenvalues are the weights. No, in the eigenvector you have the eigenvalues, and the eigenvalues divided by n are the weights, if the matrix is consistent. Sorry for that. And it was a mistake that I made in my explanation. So now, going back to our problem, I suggest you to read carefully this document, and you will see that it's straightforward. The only problem that you will find is in managing yourself through the definition of eigenvalues and eigenvectors. I suggest you not to go back to your mathematical studies to better understand what they mean. It suffices to me that you know that an eigenvector is given by this relationship, and the eigenvector gives to you the weights through a proper transformation. This is fine for me. And then you can read the other documents on Wikipedia, because they provide to you other examples. And I understand that this is a topic that, you know, it's at the beginning it's not easy to understand, but I tell you, trust me, that it's interesting. It's really interesting because it's very powerful. When you have to take a decision and convince people that the decision is objective, splitting the decision in pairwise comparison is really a very interesting way forward. Okay, enjoy your Easter break, and let's meet again next week on Thursday.